So this week we're looking at confidence intervals, and I just want to introduce my friend, the TI-8384 Calculator Extraordinaire. If you can get access to this calculator, you can actually rent it as well. And I want to share with you what you can do on this particular, with this particular tool. And I'll show you other ways you can do the confidence interval as well using the stat lab. So anytime we're talking about an interval, we're dealing with anything that obviously ends in int or interval. We begin with the z interval, which, remember, you can use that only if you have the population standard deviation. And the TI-8384 calculator, they denote the mean regardless of whether it's a population or a sample as x bar. So please don't be offended or be confused. There's still the mean. And then the sample size and the confidence level. And you don't have to split the alpha like you would normally if you're doing this by hand, in which case the calculator's doing it for you. So I have an example here where there is some mean of some sort. It's 110. I have a sigma, the standard deviation for the population of 15, and a sample size of 3, very, very small sample size. And you know what, just for the sake of this example, I'm going to increase the sample size to say 35. And then I'm going to go down to calculate, and we're going to make create a 95% confidence interval, and there you are. All right, what's really cool about this, it's, all you have to do now is add up the two extremes, divide by 2, and you'll notice that you get the mean of 110. And if I subtract 114.97 and take 110 away from it, I can figure out easily that the difference of those two values is my margin of error, which in this case would be 4.97. And the same thing would be said if I took 110 and I subtracted 105.03, I would get 4.97. So just remember this little quick little video as a resource or something you can do and use. Now the other functions that I want you to note are, if you go to stat test, notice that if you go down to number 8, you'll see what is called a t interval. You can also have data. If you have data instead, then it looks like this, right? And you just grab your list and your confidence level. But if you have stats, notice the difference here is that yes, you have some mean of some sort, whether population or other, or sample. But in this case, the standard deviation, you see how that is S sub x? That's the one characteristic that you will notice in this particular tool, that if you only have the sample standard deviation, S sub x is what we use. So if I were to use the same example we used prior, we should obtain a t interval. So let's say S sub x was 15 again, so I'll go down and I'll make that 15, sample size 110. We're still creating a 95% confidence interval, and I'll hit calculate, and there you are. There's your sample size. So again, you notice it's slightly different because we're dealing now with degrees of freedom because of the fact that this is a standard deviation of a sample, not a population. The other tool that will come in really handy here, or actually there's more than just one tool for this. But the next major point of interest is the 1 prop z int. The 1 proportion, all you need is p hat. So if you have p hat, or if you know what x is and what n is. So let's say I'm sampling 35 people out of 100, and I want to create a confidence interval to determine the proportion that is true to this particular sample. You see there the sample falls anywhere between 26% and 44%, right? And so that's when you deal with proportions, where you're dealing with discrete numbers, or in this case numbers that we count, like people, opinions, things of that nature, where we're not measuring, we're actually counting. There are other confidence interval tools that you could use here, so I'll scroll over again. So if you notice right after t interval, so z interval, t interval, then after that you have 2 sample z int, 2 sample t int, and that's the same application, it's just you have 2. And then there's also what we call a two-proportion z-interval. So I'll show you the z-interval for two sample z-int. And so notice again, sigma 1, sigma 2, so the standard deviation for the population 1 and standard deviation that we're looking at population 2. And then they ask you for the mean for each and a sample size for each. And then it's the same thing, you just select your confidence level and hit calculate. Alright, so as an example, so let's go back to our previous. We had 15 for that standard deviation. Our mean was 110. Our sample size for that first sample was 35. So let's do another mean or another confidence interval for a second population. So let's say this one turned out to be 18 for the standard deviation. And let's say that the mean in this case wasn't 110, it was 121. And let's do a sample size of say 38. Alright, and so confidence level 95, and you hit calculate, and there you are. And so that's how it intermingles both of the sectors, so it sort of brings them together. Interesting, I ended up with two negatives. And we will discuss what it means when it's negative to positive. If this were positive, or if in this negative, or if this were positive and this negative, the first thing you would want to consider is that this would mean that the sample is does not have meaning, because of the fact that 0 is a potential answer. So we would go back to the drawing board in a sense. Alright, so I hope this was helpful. This is just a little quick overview of how to use a TI-83 when doing confidence intervals.